Welcome. In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at how parameters are passed between functions and subroutines. When you are doing any programming, there will come a time, fairly soon, that you will need to use parameters between functions or subroutines. You can, of course, declare your variables as global throughout your entire application. This saves having to pass any parameters between functions and subroutines. However, it does come with a downside. While your variable is accessible from anywhere within your application, this in one way is a plus. The downside of this is if a variable suddenly acquires a value you did not expect, it can be difficult to work out exactly where that variable was changed, as it could be changed anywhere within the application. When you pass variables as parameters between functions and subroutines, this makes it easier to track down where such variables have changed, and that's what we're going to tackle today. This application has been set up so it can either be run or compiled in either the Windows or the console compilers, hence the use of this library, Common Display. So in order to illustrate the passing of parameters, let's set up a local variable within the PB main function. So we've set our data variable up as a numeric long value, and we've set that value to be equal to the number 13. So if we wish to pass the value of this variable onto something else, we can pass it as a parameter. So we're going to pass it to a function called display. And to do this, all we need to do is to type in the name of the variable in brackets. So let's now create our new function with its parameter. And here is the skeleton of this function. In brackets, we have the name of the variable we are passing and its definition, in this case as long. So within this function, we can print out the value of our passed parameter to the log by using our log function. So since this is a numeric variable, we're using the format command to turn it into a string so that we can add it on to the words value equals. So if we run our application now, we'll see that there is the value printing out on the log. So our variable, which has the value 13, has been passed to our function. Since we have not specified how the variable is to be passed, it will be passed by default as a reference. This means that the variable defined here is not passed as value, but as reference. So you're basically pointing to where the variable is stored in memory. So should we make a change to the data variable within this function, it will be reflected in its original location. So let's make a change to this variable in the function. And we can do this by using our increment command, which will add 1 to the value. If we go back to our PB main function and print out the value within this variable now, we will see that it has indeed changed. So there is the value in the function, 13, and there is the updated value when we return to the PB main function. This passing by reference is an important concept. It allows you to pass variables to functions and subroutines and allows you to change the value held within those variables. And when your function or subroutine finishes and goes back to the calling function, then the value has been updated. So by default, the definition of your parameter in the function we're calling here is by ref. You can, of course, type by ref before the variable to make it obvious that this is passed by reference. However, this is optional. If you do not type anything, it will assume by reference. So we have passed a variable which is numeric. We can also do exactly the same by passing a string variable. So if we set the value of our data variable as string and set it to the words string test, we're now going to call a function called display string, passing our variable as a parameter. And as we did before, there is our parameter within brackets. We're printing the value out to the log, and then we're adding on to that string variable. So within our PB main function, we can do exactly the same as we did before. We can reprint the value of the variable. So if we run the application now, there is our string value in the function string test, and there is our updated value string test, and more text added to the end. So we can quite easily see, both for numbers and for text, that we can pass variables as parameters. We're going to call another function now. We'll call this displayStringNew. And again, we're passing our string variable, and after return from that function, we're going to print the updated value of that variable. Note that here our variable is called strdata, indicating that this is a string variable. And in our new function, there is a parameter in brackets, but it's not called the same thing. These here are just labels on the variable. The variable itself is defined by where it is held in memory. So although we're calling the function with one label and referring to it in the function as a different label, it is in fact the same memory location because it's passed by reference. So in here, we will get this as we run the application. We can see the original change to string test and more text. We're now calling this new function once more, and we're getting the same value back. And we're updating the variable once more to add even more text. So just because you call a function with one name in the variable, it doesn't mean you have to use the same name in the function which you call. Sometimes this can be an advantage, as long as your variables make sense to anyone trying to recode your application. Having a good naming convention for your variables is very wise and will save time in the long run. As I said, if you pass the variable by reference, it can be amended within the function or subroutine that you are calling. But what happens if you do not want the value to be changed when you pass back control to the calling function or subroutine? There is another way of doing this. If we look at the display function, it's currently passing its variable by reference. If we change this to pass by value, this means we're not passing a reference to the original variable, we're passing the actual value. So since we're passing the actual value, any change made within this function to that variable will not be reflected in the calling function. So as we remember, we set the value in here and we incremented it by 1. So if we run our application once more, we will see there is the value within the function, 13, and there is the updated value. It has not changed. So the display function has taken the parameter in by value, and any change made within that function is not reflected in the function that called this one. This can be very useful if you wish to ensure that changes made downstream are not reflected in the original function or subroutine. So we have passed both numeric and string variables to a function. We're next going to look at passing user-defined types. So we will define a user-defined type at the beginning of the application. So here we have a new user-defined type. We're calling this UDT car. And this user-defined type has 4 elements. An owner name as a string, a color as a string, a make also as a string, and a car type as a numeric long value. For user-defined types, you need to specify a size for the strings. So we're setting the owner name as 150 characters, the color is 20, and the make as 150. We're also setting up an enumeration. These can be quite useful for self-documenting code. We're setting this up as a car type enumeration, and it has 4 different elements, the first of which has the value 1. Doing it this way means that 2-door will be equal to 1, 3-door will be equal to 2, 4-door will be equal to 3, and 5 door will be equal to 4 as it's the fourth entry. So let's now go back to our pbMain function and set up this user-defined type. So here we are, our new variable is called uCars, and we're defining that as UDT car. So we can now set up the values in each of the elements of this user-defined type. So I'm using the prefix command here to keep all the code together and make it look a little tidier. All the prefix command does is it prepends this string to the beginning of the next 4 lines until the end prefix command is met. So the uCars owner name is set to Fred Jones, and so on. And our car type is set to this constant, 2 door, which comes from the enumeration we did at the beginning of the code. So we have populated the uCars variable. So we're now going to pass this as a parameter to a subroutine. Again, as before, to do this we only need to mention the name of the variable within the brackets. And we're going to use our log command to print out the owner element of that user-defined type. In this case, it's ucars.str owner name. As this is 150 characters, I'm using the trim command to trim off any extra spaces on the end of this string. So let's now go and create this new subroutine. So here is the skeleton of our new process cars subroutine, taking its single parameter. As before, we're defining the name of the variable and its type, in this case the user-defined type for car. And since we have not defined how we're passing this variable, it will be passed by reference. Therefore, any change made to this user-defined type variable will be reflected in the routine that called this one. So we're going to make a change to the owner name element. So within this subroutine, I'm creating another local variable called str owner name as a string. And we're populating that variable with the value within the user-defined type. Note that as this is one variable type and this is a user-defined type, there is no collision between the name of these two variables, as this is an element and this is an actual variable name. We can print out the value of our owner name to the log, and then we're going to attempt to change the value in the user-defined type, simply by specifying the user-defined type, a dot, then the element name, and giving the string a new value. So if we run the application now, we will see there is the original value of this element within the user-defined type, Fred Jones. Having returned to the pbMain function, the value is now no one. So as we did with the numeric variables, the value of this passed parameter has been changed within the subroutine. And as we did before, you can change the logic of the subroutine to pass the parameter by value. Doing so will mean that any change made to this parameter within the subroutine will not be passed back to the calling routine. If we run this once more, we will see that the value is unchanged after we return to the pbMain function. So defining by value or by reference is a good way of limiting the extent of how variables can be changed between routines you're calling. There is a third type of parameter passing called by copy. However, we'll leave that for a later video. So we've passed variables by putting them in the parameters list. Is there another way of doing it? We can also pass parameters by using a pointer. And that's what we're going to do next with this user-defined type. First of all, we will declare a local variable, in this case called cars, just as a long variable. And we're going to use this as our pointer. And we populate that using the var pointer function. So the cars variable is going to be populated with the value of where this is held in memory. This is our pointer. And as we're passing this as a pointer, we can then call another subroutine to pass on the information. And there is the call to our new subroutine. Again, as this is merely a long variable, we're passing it just as we did before using the name of the variable. And once we return from this subroutine, we can print out the element owner name. So here is the skeleton of our new subroutine. As you can see, we're passing the cars variable as a user-defined type car as a pointer, and we're using the by-value method. So let's do what we did before, set up a local variable and populate that with the owner's name from the user-defined type. So this should print out the value of the owner name. As you can see here, the syntax has changed slightly. We're using this syntax for the name of the user-defined type, using the @ sign and the name of the pointer variable that we have passed. We can then print out that information to our log. Next, we want to update the owner. And using the syntax we used before, we use the @ sign followed by the pointer, and then the element within the user-defined type. So we're changing the value in the subroutine to have the owner name Tom Jones. So let's run this now and see what happens when we pass back control to the PB main function. And there is call, pass by pointer, the value is initially Fred Jones, and by the time we pass back to the PB main function, the value has indeed been updated to Tom Jones. So even though you pass the pointer by value, it's still updating the original memory location. This is one to remember. So another type of variable you may be passing to a subroutine or function is an array. So here we are defining the extent of a string array. It's going to be a single dimension array from the elements 1 to 10. And we're going to set the value of the first two of these, making the first element equal to Fred and the second element equal to Susan. So let's call a new function and pass these names in by reference. So there is a call to our new function, passing the name of the array, followed by 2 brackets, as a reference. As before, we're telling the function we're calling where the information sits in memory. So we'll create that function in a moment, but when we return to the PB main function, we're going to print out to our log both of those names, the one in element 1 and the one in element number 2. So let's go and create this new function with our array passed as a parameter. And again, we're using byref. So any change made to this array will be reflected back in the calling function. So we're printing out the current values to our log, and we're changing element number 1 to have the value Tom. So if we run the application now, we will see originally it is Fred and Susan, and it's now Tom and Susan. So our change made in the function is reflected in the PB main function which called it. Passing an entire array like this does allow you to pass a great deal of information from one function to another. So what if you only want to pass a single part of an array and not the whole thing? You can do this quite easily by specifying the element within the array. In this case, we're passing a single parameter, which is element number 1 as a string. So here is our new process name function with its single parameter. In this case, as we're passing the first element of the array, we only need to define this as a string in the function that we are calling. So we can print out to our log the value that's come in on this parameters list. And we're creating a new local variable, and we're populating that with the word value and the value that come in the parameters list. So let's now pass that information on to another function. So here is the new function we're going to be calling, and we're going to be passing this new name variable onto it by value. And after we return from this new function, we will print out the value in the new name variable. As you will remember, since we're passing this by value, any change made within the process name by value will not be reflected in this process name function. So let's create this new function. And there is a new function taking in its single parameter by value. And we're adding on to that 2 asterisks, and we're printing out this to the log. So let's try running the application now and see what we get. So there we have the element of the array, the amended value with the 2 asterisks, and the original value being printed out. So in summary, what we've done today is we have set up an application which can call a number of functions or subroutines passing a single parameter. We have passed a string parameter, a numeric long parameter, a user-defined type, either as a pointer or a reference. We have discussed passing parameters by reference and by value. In today's video, we've been only passing a single parameter to each of these functions and subroutines. You can, of course, pass multiple parameters, and we have briefly touched on the subject of passing pointers. There is much more to cover for passing parameters, but we'll leave that for another video. That's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.